In this example, we're going to complete the following proofs. Here in part A, we're given that C is the midpoint of BD. We want to prove that BC is congruent to CD. So when you're proving a statement here, it always goes last, and then the given information will come first. So let's write down that given information. C is the midpoint of BD. And that reason is just that it's given to you. The last statement is BC is congruent to CD. Our proof statement will always come last. We need to come up with the reason though. So if we look at the diagram here, again we're given that C is the midpoint of BD. That means that BC is congruent to CD. Why? Well, that's just the definition of a midpoint. So you can list as a reason, you can list a definition or a theorem or a postulate. Sometimes it's as easy as just listing the definition. That's what it means to be a midpoint. Let's look at the next one. We're given the diagram as shown. Alright, and we want to conclude that PON is congruent to SOQ. So we can write diagram as shown. And for part 2 here, we're going to write our proof statement. It's the last, so we can write there. And some proofs are very long. You might have more than just 2 for sure. You could have a 7 or 8 step or even more step proof. And that proof statement would be the last one. We need to come up with a valid reason though. So here's PON here, and here is SOQ. Well, if you look at that, we've got a pair of intersecting lines, and these are non-adjacent angles. They don't share a side. And so these are vertical angles. And one of our theorems is that vertical angles are congruent. And that allows us to prove the statement that we were asked to prove. Looks like we've got a part C here. I'll get that up on the board for you. Okay, so part C. We're given that a triangle TCD is isosceles with base DC. So let's write that down. In the given, triangle TCD is isosceles with base DC. And that's just given. Well, here's base DC, and that means that TD is congruent to TC. It doesn't look like it in the diagram if you actually measured it, but diagrams sometimes are not drawn to scale, and so we only want to go off of what we're given, or if we had tick marks here on the diagram, we could do that too. We're asked to prove here the last statement that TD is congruent to TC. Well, we can prove that because that's just the definition of an isosceles triangle. That's what it is. Isosceles triangle, the two legs are congruent. And we know that the base is DC, therefore TD and TC must be congruent.